Okay, so we're going to look at how the body inspires and expires. And it does use the internal and external intercostals as well as the diaphragm that we've already covered. So the pressure inside the lungs will decrease, and the body doesn't like that. The body likes equilibrium. So it likes to have the pressure on the inside the same as what's on the outside of the body. So what happens is we want to rush air into the lungs in order to keep that pressure the same. So when air pressure inside the lungs is decreased, air will rush in. In order to decrease the pressure, we need to increase the size of the thoracic cavity, so we open up the lungs more. So at rest, the diaphragm will contract, and that will move down, which will open the thoracic cavity so that the air is forced in. During exercise, and you are like to be asked about this in exams, it will change. So you'll be asked about how it changes. So your diaphragm will work hard, but you will also then use the intercostals to be able to inspire and contract further. So that contraction will help to expand the ribs, open even further to be able to draw more air in. For expiration, it's the opposite, but in a more of a relaxed phase. So the diaphragm actually relaxes and chills out. So this is more of a passive process. So when the diaphragm relaxes, it allows the rib cage to depress and kind of go back in. And so the lungs will recoil as such. The diaphragm has got a shape that divides it from heart and lungs, from the organs and digestive system and things like that. So the thoracic cavity is anything above that diaphragm. And this muscle requires its own air supply. So if it doesn't get enough oxygen, some of you may have experienced a stitch. That is arguably what a stitch is. There's a lack of oxygen to that muscle. So during exercise, this takes a bit of a different shape. So in order to then force more air out of the lungs, we then call upon the intercostal muscles again to further the contraction of the rib cage to decrease, to squeeze more air out. So on the left, we've got a full expiration, and this is somebody that has breathed all the way out as far as it can. And on the right, you can see the difference in the lung capacity there from one side to the other. So as looked at already, one lung is usually a different shape to the other one. So we've got 3 lobes in the one on the right, and then only 2 lobes on the one on the left, and that's to accommodate things like heart and valves and things like that. And there's a simple picture of how the chest and the space between chest compresses and decreases the size so that air is squeezed out, and how the diaphragm allows more space to draw air in.